Hey, Algebra 2, welcome back. Here is 6.6, our last section of Chapter 6, Solve Radical Equations. Okay, here's our last section before we embark on another checkpoint. At least for this semester, if you're watching this in the future, might not be the case. Our objectives for this section are to solve equations that either contain radicals or contain rational exponents. Okay, and then it's also to identify extraneous solutions in radical or rational exponent equations. Okay, so we have this idea of extraneous solutions coming back to us. Okay, and we'll see in a little bit why we have those here as well, and not just in back in chapter 8, right? So the idea for this section, to solve these equations, we want to get the radical / rational exponent expression by itself. And then eliminate the radical or the rational exponent. Okay, and we'll see what that means here, right, with our first example. Okay, so solve the following radical equations. All right, starting with A, solving cube root of 2x plus 7 equals 3. Okay, just like how if I want to solve the equation x cubed equals 7, I would take the cube root of both sides because the cube root will cancel out the cubed. This is backwards. Okay, if I want to get rid of the cube root, I need to raise both sides to the third power. Okay, they're inverses of each other, so that worked here as well. This will, these will cancel each other out. They will undo each other since they're inverses. And so I have left 2x plus 7 on the left equals 3 to the third power is 27. And now it's a normal equation that we're so used to solving, right? So subtract 7 on both sides, 2x equals 10. Ooh, got ahead of myself. 20, and then divide by 2 to get 10. Okay, there's our answer. Okay, not terrible at all. Okay, the new skill is here at the beginning, raising both sides to that exponent, and then from there, just solving. Okay, so let's keep on trying it. The next one, square root of x plus 25 equals 4. How do I get rid of a square root? Well, that's technically the second root, so I'm going to need to square both sides, like so. So this will undo each other. X plus 25 is equal to 16. Okay, subtract 25 from both sides. X is equal to negative 9. Okay. Awesome. Oh, excuse me. I don't know why I'm yawning. It's a little bit late, I guess. Apologize. Next one. Cube root of x minus 9 equals negative 1. So here's kind of where that little hint at the beginning comes into play. Make sure we get the radical expression by itself first before we raise each side to the third power. So first thing I want to do is add 9 to both sides. I get cube root of x is equal to 8. And then here is where we raise both sides to the third power. So I get x, because these will undo each other. X is equal to 8 to the third power, which is not 216, 256, right? Now I feel very unsure about that. I need to check. I might be completely wrong. 8 to the third power. Yeah, I was very far off. Oops, ignore that. 512. Very different. I'm mixing up my powers. Okay, 8 to the third power is 512. All right, and then last part of this example, 2 square root of x minus 3 minus 4 equals 0. We'll start by adding the 4 over. I get 2 square root of x minus 3 is equal to 4. Then I can divide both sides by 2 to get rid of this 2 out in front. That's going to be x minus 3 square root is equal to 2. Maybe something you're tempted to do is distribute this 2 in here. We can't do that because of the square root, right? So to make sure you don't do that. And then now here we can square both sides. So I get x minus 3, because those will undo each other, is equal to 4. Add the 3 over, I get x is equal to 7. Very nice. All right, so now let's try some examples with the rational exponents, okay? So first one is 4x to the 2/3 equals 36. It's kind of a similar idea. We want to get the expression with the exponent by itself. This 2/3 does not apply to the 4. So I want to get this alone. I need to divide both sides by 4 first. I get x to the 2/3 is equal to 9. And now here, it's not as simple as just squaring to the 3rd power to the 4th power, right? Here, what I need to do is raise both sides to the reciprocal of this exponent. Okay, so instead of 2/3, I'm going to raise it to the 3/2. And of course, I got to do the same thing to both sides. Okay, so 2/3 times 3/2, that's 1. And so that's the whole point behind doing the reciprocal. So now I have just x left because those will multiply to become 1. And then I have 9 to the 3/2. Okay, keep in mind that half, this one tells us the index of the radical if I were to rewrite this in radical notation. So this right here is a square root, technically. And what happens when I square root both sides, or when I do an even root on both sides, I need plus minus, right? So it's going to be plus minus 9 to the 3/2. Okay, always start by doing the denominator first. So 9, I would actually just rewrite this completely. So plus or minus square root of 9 to the 3rd power. Square root of 9 is 3. 3 to the 3rd power is 27. And so x is equal to plus minus 27. Okay. Remember that these two things are equal based off of what we did in chapter 6.1, right? Okay, same idea for b. Get the exponential expression by itself. So I got to add 1 to both sides. I get x plus 2 to the 3/4 is equal to 8. And so what I have to raise both sides to in this case is going to be 4/3, the reciprocal of that side. 4/3, those will undo each other. 3/4 times 4/3. Now 4/3, that root right there is odd. It's the cube root. So I don't need a plus minus here. Okay, so x plus 2 is equal to 8 to the 4/3 power. No plus or minus because I have an odd root. Let's figure this right-hand side first. This is going to be the cube root of 8 to the 4th power. Okay, cube root of 8 is 2. 2 to the 4th power is 16. So then I just have to subtract 2. And I get x is equal to 14 is my answer. All right. So then now the last thing for this section, not a terribly long section actually, is when we have variables on both sides, that actually means that we need to check for extraneous solutions. Now, why is that the case? Let's look at A. X plus 1 is equal to the square root of 7x plus 15. Okay. If I think back to B from example 1 here, if this equation said square root of x plus 25 is equal to -4, okay, and I asked you to solve this, this would actually be no solution. Now maybe take a look at this and think why, why? Because I would just square both sides. This becomes positive 16 and that becomes x plus 25. What's the issue? Well, think about the range of the square root function, okay? Can I square root something, like have it just be there like this and get a negative answer? No, right? So even though we can do the math and get an answer, domain and range wise, this does not work out. This is not even a true statement, okay? We wouldn't ever write this, Okay, make sure you kind of keep that in mind. I might end up putting this on the checkpoint because it's a really important concept to understand. Because even though we can do the math, we can solve quote unquote this equation using our skills, it's not containing a real solution. There's no solution to this because we can't get a negative number out of a square root, okay? The only time I can do this is when I use the square root as an operation, because then I have to attach the plus minus, right? Okay, and so here in this first equation, this is 4, just 4. There's nothing that can change about that 4. It's gonna stay 4 unless I do stuff to it here like I did right here, right? Unless I do that, this is gonna stay 4. 4 doesn't change. X plus 1, on the other hand, isn't always the same number. It depends on what x is, right? And so this can have both positives and negatives, okay? But when I square this out, I'm getting rid of the negatives, okay? And so when I get rid of the negatives, that kind of lets me kind of take a solution without really asking, okay? I might end up getting more than one answer because it's gonna get rid of the negatives, okay? And so you'll see right now that we're gonna get 2 answers, but only one of them is gonna work, okay? So let's go ahead and do that. All right, our square root is already isolated. So I can square both sides. Square, square. Okay, remember how to square this. You got to distribute. So this becomes x squared plus 2x plus 1. I kind of did that. I did that pretty quickly. So if you need to multiply this out yourself, go ahead and do that if you're still having trouble with it, right? We have to write it out like this and then distribute twice. Okay. So x squared plus 2x plus 1 on the left is equal to 7x plus 15. Okay, we had trouble solving stuff like this on the last checkpoint, even though we know how to do this. We've done this in lots of other checkpoints. So remember, whenever we have a quadratic and we have an x term as well, we need to get everything to the same side so that we can factor. So let's subtract 7x and subtract 15 on both sides. I get x squared minus 5x minus 14 is equal to 0. So then if I factor this, what two numbers multiply to negative 14 but add up to negative 5? That's going to be negative 7 and positive 2. So then my answers, supposedly, are 7 and negative 2. Okay, we have to check which one is actually going to work. Okay, now we can immediately find the answer here by just plugging them into the left side. Okay, if I plug in x equals 7 to the left side, oops, I need to get back up here. There we go. If I plug in x equals 7 to the left side, I get 7 plus 1, which is 6, is equal to, actually nix all that. I try to give you like a really cool way to think about it, but that might be too complicated. Let's just, the thing you need to do is plug it into this equation and see if it's true. So 7 plus 1 is equal to the square root of 7 times 7 plus 15. Okay, 7 plus 1, that is 8. Okay, this is going to be square root of 49 plus 15. 49 plus 15, that's 64. Okay, and we should have a question mark here because we're wanting to know, is this the same? Is square root of 64 8? Yes. So x equals 7 is an answer. Okay, now let's try x equals negative 2. Okay, spoiler alert, this is the one that's not going to work, right? So x equals negative 2. I get negative 2 plus 1. Is that going to be equal to 7 times negative 2 plus 15? Okay, negative 2 plus 1 is negative 1. Is that equal to negative 14 plus 15? Negative 1, is that equal to the square root of negative 14 plus 15 is 1. Is the square root of 1 negative 1? No. So this is the extraneous solution. Okay, and I want you to do it just like that. I want you to show this work. I want you to tell me which one of these is the answer and then write extraneous next to the one that is extraneous, right? Okay, so whenever you have variables on both sides like this, some outside of the square root, some inside, we'll need to check for the extraneous. Now, if it's a cube root, remember, there's no issues with cube root. My domain is all real numbers, my range is all real numbers. So there's never going to be an issue with a cube root. Now for this last one, we have square roots on both sides, nothing we can move around, so we can just immediately square both sides. Okay, and then I'll get rid of my radicals. This is 2x plus 5 is equal to x plus 7. And so then I just solve. So minus x and then minus 5. I get x is equal to 2. Okay, and if I check that really quick, 2 times 2 plus 5, that's a 5, I promise, that's just really ugly. Is that equal to square root of 2 plus 7? Okay, 2 times 2 is 4, plus 5 is 9, square root of 9. 2 plus 7 is also 9. Is the square root of 9 equal to the square root of 9? Yes. So that solution does work, okay? All right, so that was just a few different kinds of radical equations we can encounter, right? So just kind of make sure you remember this idea of extraneous, as well as remember with the exponents, the rational exponents, if your index, if your denominator is even in that rational exponent, you'll need that plus minus, right? Not when it's odd though. All right, last section of chapter 6. Hope you enjoyed it. See you later. Have a good day.